Hi everyone, we continue to smart question in physics topic from the conversion of galvanometer to ammeter or to voltmeter. Okay, now let's see the question. The question says a galvanometer has a resistance of 2.5 ohms, gives a full scale deflection when a current of 10 milliampere passes through it. How can it be modified to act as ammeter reading to 2 ampere? How can it be modified to a voltmeter reading to 5 volts? Okay, now the question now it says, how can you convert this galvanometer that can read only 10 milliampere? How can you convert it to read 2 ampere? And after that you now convert it again to become voltmeter in order to read 5 volts. So it's two questions we are going to solve here. Converting this galvanometer to ammeter to enable it to read 2 ampere, and also converting this galvanometer to voltmeter to enable it to read 5 volts. Now, in order to convert it to ammeter, we are now going to connect a very small value of resistance called shunt in parallel with the meter. If we do that, we now succeed in converting it to ammeter. Now it has formula. Let us treat this number I first. Okay, the formula says Rs equals to Rg times Ig all over I minus Ig. This is the formula we use to calculate that small resistance called shunt. So the resistance here, Rs, stands for this shunt we want to calculate, okay, equals to the resistance of the galvanometer, which has been given here to be 2.5, times the current that the galvanometer can measure, which is 10 milliampere, all over the main current we want it to measure now, which is 2, minus the current of the galvanometer, which is still 10 milliampere. So Rs stands for the shunt resistor we now connect in parallel to convert it to ammeter, while Rg stands for the resistance of the galvanometer, which is 2.5 ohms. Then I stand for the current of the galvanometer, which is 10 milliampere. Then the main I here, which is another current, that this is the main current that we want to measure now when we finally convert it to 2 ampere minus the same current of the galvanometer, which is now, we now calculate the shunt equals to 2.5 times, which is the current of the galvanometer, times 10 milliampere, and we will now convert this 10 milliampere to ampere. Dividing it by 100, we now have 0.01 all over 2 minus 0.01, okay, which now the Rs equals to, when we multiply these two, now we have 0.025. when we multiply 2.5 times 0.01 all over, we now take away this, we now have 1.99. Now when we divide the up one with the down one, what do we have? 0.0126 ohms. Can you see that this is a very small resistance? When we connect it in parallel with the galvanometer, it means that we have converted it to ammeter that can measure 2 ampere. Now let's calculate for the second one. The second one is to connect a shunt, a high resistance, in series with the meter. To connect a high resistance called multiplier, we have now succeeded in converting it to voltmeter. Now the formula for it is Rm equals to V minus Ig R G all over Ig, which is, they stand for the multiplier resistance equals to voltage we want to convert it to, minus the current. I've told you this before, current of the galvanometer and the resistance of the galvanometer all over the current of the galvanometer, which is equals to 5, the current we want to measure it with, minus the same thing here, okay, 2.5 times 0.01 all over 0.01, which will now have this 2.5 times 0.01 will now give us 0.025. Okay, we'll now use 0.025 and subtract it here. What do we have? We now have 4.975 all over 0.01. When we now divide 4.975 all over 0.01, what do we have? We now have, using our calculator, have 497.5 ohms. Can you see is a very high resistance to compare to the resistance of the galvanometer? Is very high. So if we connect this resistance, we connect this resistor in series with the galvanometer, we now succeeded in converting it to voltmeter that will read 5 volts. Thank you so much for watching. Please make sure you subscribe and follow me. God bless.